Hello, this is Federico, one of the developers of the two-stratum SEIRS model. With me here is Levan. What we are going to show you today is how to refit some parameters, which is a usual problem when people start playing out with our simulator. So what we are going to do is to take Madrid, which is one of the examples that we have in the paper. And as you can see here, you can access it online from these locations, sartosair.com, paper 10, 2020. And the idea behind this is that this is the actual behavior that we expect to see from Madrid after the parameters, the isolation parameters are set up. Because we don't want a third phase with any mitigation whatsoever. What we are going to do is just set up it in 0, and we're going to update the simulation. As expected, the second wave actually moved below, so it gets pretty near to the original. So if you take all suppressions away, this is the expected behavior that you could expect in the epidemic. Now, one interesting thing that we can change is below we have all the parameters, and one normal change or one parameter that's under discussion is the actual R0, that this is unmitigated R0. So because the range is between 2.5 to 3.3 more or less, we decided to go 3.3 for the paper. But we can actually go and say, okay, let's set it up in the 2.5 range. So if you look at it, what we are going to do is we are going to update the simulation, and there you can see essentially what it happens. Because we have a lockdown here, the wave actually disappears, so we wouldn't be able to see it. But this is actually a problem, and I'm going to tell why. Because if you look at the total expected deaths, this is the model deaths, this is the actual deaths. So there is no match. The same thing happens with the 7-day max deaths in here. So this is to us the most important mistake in using our model. You have to actually refit it. Okay, so it's pretty important to refit, and you actually see that now you have the proper behavior. So interestingly enough, you probably haven't looked at it before, but the immunity is 39% here. But if you look at here, this is the model cellular radio that was reported by the model. This is the one that this is the number that actually serology studies found on the ground. So essentially what we need to do is to actually look at this and figure out how to push this 33 number into 79. So what we are going to do is to change this parameter here, which is the isolation to the healthy. And we are going to hit refit again. And you will see that now it has changed to 0.77. And the immunity has also changed to 40%. And you can see here how it has changed, barely anything, but anyway, no problem with it. So, but the problem is we're still not there. So we will try a different number, which is, I don't know, 68. So then you refit and you find out, okay, we have a match. So now we can be sure that external validation information actually shows the same information here. So this would be the expected. If you look at it, this is interesting. If you look at it, see how the 2.5 version actually did not match the death here. This is interesting. Say we instead of this, and remember, this is immunity 41%. Say instead of this, we decide to go 4 here. Okay. So in this context, if we do that, you will see that the behavior is very, very different. But now again, the total deaths and the 7-day max death actually go haywire. So essentially what we have to do is to refit again. And because we refit, now we have a matching curve for the deaths. Now the question is, does our serology ratio match again? No, clearly it doesn't. So we can actually do the same thing, which is like saying, okay, we are going to go to 78 and retry again. We were almost very near with it. And as you can see, this is the behavior. And we are going to try another one just to make sure that we match here. Now, here's the interesting part. When you look at it, it has entirely different behavior. But interesting, even if we change the R0 parameter, the actual immunity that you would have obtained through the isolation is 41, which is the same for the case of 3.3 and the same for the case of 2.5. So hope this does explain how the process of fitting the data is done, and also shows you that immunity of the R0 parameter, the sensibility for the immunity of the R0 parameter is actually 0, as we reported in the appendix 2 of the paper. Thank you very much.